Hello, everyone, and welcome to our webinar, Beginner's Guide to Vector Databases. My name is Matt Brown, and I'll be your moderator today.
Yeah, let's get started. So this is the table of contents. I'm going to talk about databases in traditional applications, and we will also see the difference between vector databases and traditional databases. We will see what are vector embeddings and how vector databases work, what is vector search, and vector databases use cases, where all they are used, and we will also see how SingleStore can be used as a vector database and a simple demo through a simple demo. So yeah, if you see, a database for a traditional application, take for example a banking application, right? You open your app, the first thing you see is the UI user interface, and you want to see, for example, your account balance. The business logic kicks in, and the data, the relevant data is retrieved back to the user, to you, from a database. So here in this image, the database is shown as a very important part of the application lifecycle in storing, managing, and retrieving data, right? So it also, and also in the traditional database, the data is stored in rows and column format, the JSON and all that, right? But what if you have a high dimensional and highly unstructured data, right? A large amount of unstructured data. How do you store it, right? So that is where the vector databases come into play. If the data is like this, right, which is very unstructured, you have images, audio, video files, and all that, right? So just for example of the overview of how vector database stores data, it's in a three-dimensional space. It basically stores the similar words together. For example, here you can see in a three-dimensional space X, Y, Z, thirsty, drink, and hungry food, they are related. Thirsty and drink is related, that's why they are a little closer. Food, watermelon, hungry, they are closer. And car, bicycle, they are closer, that's why they are more closer to each other. So this is just the overview. We're going to go again a little in depth in the future slides. So yeah, why there is so much boom about vector databases? Because if you go to Google Trends and search for this keyword from last year, from, I mean, 2022 and almost 2023, right? Uh, it started. You will see a growth. The search volume is so much that all the companies they want to invest MS databases and GenAI applications to store this unstructured data that GenAI applications have. They need vector databases. That's why everybody is, investing heavily in vector databases. So you might ask, hey, Pawan, what is the difference between a traditional database and a vector database? It's very simple. Like, we can divide everything into basically four primary things, like the data type, structure, how the data is stored, and what it is optimized for, and how the search method works. So for example, in traditional databases, the data type is basically scalar data, and the structure is basically rows and columns. That's how it is stored. And it is, traditional databases are optimized for transactional data, and the search method is a simple SQL query that you use. But in vector database, the data type is basically vector data. We're going to see what is vector data. And the structure is, it is stored in a three-dimensional space, we saw right there in the previous slide. So, and it is optimized basically for AI and machine learning applications. And the search method is similarity search. We will see some of the search methods in the upcoming slides. So this is the major differences between, some of the differences between traditional and vector database. So how vector database basically stores data? You see here, structured, unstructured data is gathered, and it goes through an embedding model. Basically, I've taken example of OpenAI's embedding model, text embedding model, ADA002. And then the text is split into small chunks of words, and each chunk of word is assigned with a numerical value. That's how the vector embeddings are created, right? And then these can be, all these vector embeddings are stored in a vector database, in a database called vector database, and even SingleStore supports vector data. So let's talk about vector embeddings. Like we saw, right, input from various sources comes together, and then it goes through embedding model, and then that's how vector embeddings are created. Like the chunk of words are given a numerical number, numerical value. So if you see, embedding vector captures contextual meaning, and basically text with similar content will have similar vectors. We can see how, right? Again, right here we can see three examples. My dog Rover likes to chase squirrels. Fluffy, my cat, refuses to eat from a can. The Chevy board accelerates to 60 miles per hour in 6.7 seconds. If you see, the first two sentences are more like about pets. They are very similar, and they are placed together, almost together in a vector database. Whereas if you compare three and two and three, they are not that similar. That's how they are they are placed a little apart in a vector database. So this is how vector embeddings there are. If there is a audio input, audio source or audio input, there is an audio model, like for example open L3. That's how the vector vector embeddings are created. There is a text. There is a text embedding model. That's how text embeddings are created. And if it's a video source, there is a video model like YOLO or something. That's how video vector embeddings are created. So let's go a little in depth about vector databases, right? Like we saw, external data from various sources from the internet, Wikipedia, audio, video files, YouTube video, and split into everything is split into chunks of words, and this is called tokenization, right? So and then this chunk of word is assigned with a numerical number, right? That's how embeddings are created, and all these embeddings are stored in a vector database. Let me show you like tokenization, how it is created, right? If you go to OpenAI, there's a tokenizer. You can go to OpenAI platform. There's a tokenizer. If you see, Pawan is a developer advocate. If I see that, the tokens and the characters change here, and all these things are given with a numerical value. If I try to delete some, and again there are 5 tokens and 20 characters. So that's how tokenization happens, and that's how everything is, the embeddings are created, and then the embeddings are stored in a vector database. So basically, there are two steps. One is storage, and the other one is retrieval. What happens when a user asks for any query, right? So, like we saw, right, a source from external data from different sources, it goes through data extraction, like, right, the whole content, the whole text, the content, audio, video, everything is split in small chunks of words, and each word is assigned with a numerical value, numerical number. That's how embeddings are created, and we need a space to store these embeddings, vector embeddings, and we have a vector database. This is about storage. And what about the retrieval, right? So user comes in and he asks a question, a prompt. Basically, even his question gets converted into an embedding, right? If you see here, his question also gets converted into an embedding, and it goes through a vector database to find most approximate similar type of chunk. So basically, it retrieves back the relevant chunk, and again, it goes back to the LLM model, and that's how the answer is given back to the user. So basically, if you see, first data gathering, next data extraction, splitting the chunks, and then embeddings creation, vector storage, prompt and search, and then the output generation happens. So this whole thing can be divided into two parts: storage and retrieval. So the same thing, right? The From different sources, the data goes into an embedding model. You see here, we only talked about in the previous slides about OpenAI's ADA embedding model. Here you can see Cohere. There is Hugging Face. You can use many other embedding models. That's how embeddings are created, which are stored in a vector database. And then when a user query comes in from above, right? You can see here, it goes through an embedding model. Even the question gets converted into an embedding, and also the search happens inside a vector database, and then the approximate nearest neighbor is given out as a result, basically. So representing unstructured data as vectors. For example, if you have unstructured data as, for example, these two, right? One is cat, one is dog, and embeddings are created for this through an embedding model. And this is how, in a three-dimensional space, it is the two vectors are stored in a vector database. But how vector database gets to know the type of data I need to retrieve back to the user, right? So there are different methodologies in search, in vector search, like Manhattan distance, cosine distance, dot product, Euclidean distance to find the distance between the vectors. So how they are represented, right? So Manhattan distance is basically in a stepwise. If you go to step by step from A to B, that's how Manhattan distance is calculated. Euclidean distance is basically how a bird flies from A to B, that distance. And cosine distance is basically the degree between two vectors. And dot product is calculated like this, like, the perpendicular distance between the two vectors. So yeah, vector search. So let's talk about vector search. Uh, for example, take for example an e-commerce store. You want to find a similar shoe in a vector in an e-commerce store. And the shoe is converted into a query vector. It goes through a vector database. A vector search happens, and similar representation. The query, you know, the similar embedding is retrieved back. That's how the vector search usually happens. We can see it clearly in one of the examples here. This is a real life example we know from Misho. Misho is, I think it's only in India. It's a e-commerce website. So basically people go there to buy, to do shopping. And so you first open the app, you search by image. You want to get a bottle like this. You capture the image, you upload it, and then the visual search happens, and it retrieves back the related bottle types that are available in this website, and then you add to the cart. So that's how the whole vector search usually happens. This is just a real life example. So again, vector database use cases. There are many use cases. I have taken some examples here, right? If you see Netflix, you might have watched something and it will recommend you, hey, you have watched this. These you might be interested in this. For example, here because you liked Marvel's Jessica Jones, you might like Daredevil, something like that. So customers, even Amazon.com, right? Customers who viewed this item also viewed that. So it will show these recommended items. Even if you go to Google, right, if you want to search for a long tail keyword, what is vector database and how vector search works, it will not give you the direct answer. It will give you approximate nearest answers, right? That's how the Google search works. So there are many other use cases like threat detection and all. You can use a vector database, uh, vector search basically. So single store as a vector database, same, right? Unstructured data goes through an embedding model, OpenAI's embedding model, which are converted into vector embeddings, and you can use single store as basically as a vector database. So let's do. I have a simple demo. So these are some of the simple prerequisites. You need to have a single store DB free cloud account. You need to have OpenAI API key and Postman account. Why we need to have a single store DB free account? Because that's where we're gonna store our vector embeddings. How we are going to create vector embeddings? Through Postman, right? Postman is basically an API platform. Okay, so you can scan this, or you can just go to singlestore.com, and then go to singlestore.com, create your free account. The first time if you create, you will get $600 free worth credits. So you can play around. We have some amazing features. So the first thing after sign in, the first thing you need to do is create a workspace. So this is how you create a workspace. I'm already signed in. So yeah, check starter or standard, give a name to your workspace, and select AWS as cloud provider. I have already created my workspace. My workspace name is PowerApp Workspace. And if you see, uh, next thing is to create a database. So I'll go here. I'll create a database. I already created a database under my workspace, that is vector database. You can create like this. It's very simple. Just create a create a database under your workspace. I already have a database created under my workspace. Okay. So next thing is go to postman.com. That is the API. That is the API platform you're going to use, and create a workspace here also. Once you create a workspace, you come to this basic dashboard. We're gonna hit this particular API key, API endpoint, because if you go to overview, go to openai.com API reference, how to create embeddings, this is where it's written, right? We'll hit this particular API endpoint here, and we'll use post, and we'll basically add it. The first time when you're doing it, it'll ask you for the authorization. Use your Open AI API key to authorize. And here we will mention the model name and the input. Input is basically our text. What we're going to do is we're going to convert some text into embeddings. I'm going to show you how the embeddings are created. So this is the model text embedding ADA002 from OpenAI. And if I just type Gen AI or anything, right? Pawan is a developer advocate. If I hit send, you can see here embeddings getting created. Right. So we're gonna store these embeddings in our database that we have created. So we will go to, so we have created a workspace on SingleStore, and also we have created a database under my workspace. We will go to simple SQL editor. So 1 second. Yeah. You need to select your workspace here basically, and your database that you have created. What we will do is we will create a table in our database. So this is the thing to create a table. I have already created a table with the name my vector table. You can see here it's already created my vector table. Okay, we'll go to SQL editor. So the thing is, now let's create embeddings and store them in our database. Let's take, for example, what we'll say, Gen AI is so cool. So we'll convert this particular thing into embedding. We got the embedding, and then we will insert those embeddings into our database. Right? We did this, we created. So this is how you insert this. We have already used it here. We are inserting these embeddings in our table, my vector table. Basically, I'll copy this. I'll change this hello world. It was basically, this is where I'll add the embeddings. I'll copy these embeddings. Control C, add it, and then run it, right? If you see what I have added, you can go to the database, vector database, our table, and then sample data. You see, GenAI is so cool. So that's how vector embeddings are stored in our database, right? So next, what we will do is we added that. You can do that for all these examples like OpenAI vectors. Just copy this, go here, change this, add it, hit send. The embeddings are created for this particular input. Similar fashion, go to SQL editor, add it, right? So basically I have added most of the text. I have stored many vector embeddings, if you see. All right. So I showed you one example. You can do it yourself. Okay. So next, what we're going to do is we're going to do a search and see how the vector embeddings are ranked, for example, right? Next, we will perform a search in the database against the existing embeddings. So let's search for the word Gen AI. Okay. So same, we will search for the word Gen AI. We'll first create an embedding for this. Create it. We will use this particular. And then here we will add the embedding that got created for the input Gen AI. Now I'll hit run. You can see the score, right? So you see, I have already added these texts like we saw. That's how the score is calculated, right? The most nearest to the Gen AI. Gen AI is so cool. That's what we added. Gen AI transforms the world of technology. Gen AI empowers creativity and innovation. So these are already added. So that's how it retrieves and gives a score. That's how efficiently you can use SingleStore as your vector database. And yeah, you can try this. I have a complete article. The tutorial is being shared in this particular article. Right, the tutorial is shared. Deep dive into vector database. If you go to singlestore.com, there's a blog, right? A complete guide to vector databases. So yeah, follow me on LinkedIn. I'm very active on. I basically share AI, ML, data science related content on LinkedIn. Yeah, you can basically let's connect on LinkedIn if you have any questions, and let's get connected there. So yeah, that's how you can use SingleStore as a vector database. SingleStore, many companies use SingleStore for their real-time analytics also. So yeah, that's it from me. Yeah, Matt.
Awesome. Yeah. Let's switch over to the live Q&A. And everyone is welcome to participate. I know we've already got a ton of questions coming in, but if you'd also like to participate, just click that Q&A button at the bottom of your Zoom console, and we'll get into it. We also have Akmal online, so Akmal can help out with any of these questions. And I think between Akmal and Pavan, we'll be able to knock out most of these. The first one I see here is from Kofi. How are audio and videos stored as vectors? You want to handle
Yeah,
that,
true.
Akmal, maybe? Sorry, go
Yeah,
ahead,
Akmal.
Pavan.
Yeah,
Akmal.
like I saw. Yeah, Akmal can.
Yes, Pavan. So I was just going to say, this is this concept of multimodal, not to be confused with multi-model. SingleStore is a multi-model database system, but it can be multimodal as well. So I think traditionally, historically, if you look at things like OpenAI, I mean, where did it start? It was all about chat, wasn't it? Text. ChatGPT, right? So we've known for quite some time how to deal very efficiently with text. Okay, it's just taking these sentences, creating these embeddings from them, okay, from using the LLM, just storing them, and that's fine. And then, of course, people are interested and say, well, look, what about audio? What about video? Well, if you look at the likes of these LLMs now, okay, they are providing these so-called multimodal capabilities as well. So they are able to generate embeddings from these types, which just makes it much more exciting. At the end of the day, I mean, it's just vectors, okay? What is a vector? It's just an array of numbers, okay? But it's the algorithms, the techniques that they use, the transformers and so on that they use to do this. So I think the best thing to do is to check with your favorite LLM, whether that happens to be OpenAI or you're using something else, Cohere or something. Just have a look at their website. Plenty of new examples appearing all the time, and I think you'll find lots of great sort of content showing how to do these. We should probably we're doing this soon, aren't we, Matt? I think this is coming up very soon in one of our webinars. So we'll be covering this topic as well in more detail. But great question.
Indeed.
Thank you very much for that. Yeah, awesome question.
All right, good stuff. Akmal, I'm going to give you another one. This one's anonymous, but are there databases out there that offer the functionality of data warehouses, analytics, and vectorization all in one?
Yes, it's called SingleStore DB. We are biased, though. It's obviously, But I think seriously, if you look at the database space, and Pavan may have some views on this as well, but essentially, I mean, look at the world of database systems, look at the products that can do OLTP and OLAP and vectors. That space is very, very small. Like I said, I mean, we do it. We can do all of those sort of capabilities. And historically, we come from the OLTP space. So we added the OLAP capabilities a few years back, analytics. And keep in mind that vector support in SingleStore has been there since 2017. So we are not just jumping on the bandwagon just because everybody else is doing vectors. We've actually had it for quite a long time, although all the cool stuff is coming, or more cool stuff is coming on Wednesday, which was one of the earlier slides that Pavan showed you. Pavan, I think you've got some, maybe have some thoughts on this as well. But essentially, I mean, look at us first. We're awesome, okay? But I think maybe one or two products might be out there. Let's put it that way. So yeah, just to be fair.
Yeah. Vector database is just a small part of what SingleStore does, but SingleStore does a lot of things, and also many interesting features are coming up in the I think in the next webinar, I think on 24th. So I think you guys should join there, and yeah.
Agreed. So, Pavan, I'll give you this one. There's been a couple questions about the step where you're creating the vector embeddings, and there's questions about, are these being saved in SingleStore? And I know in previous webinars we've gotten a lot of questions about, can you get the metadata in SingleStore and the vectors in SingleStore? And what if you've generated vectors from a different LLM? Are those vectors compatible with each other if you've used like OpenAI versus Llama or something? So I'll just try to aggregate those questions into one.
Yeah, I just used here OpenAI's embedding model. I have not done with the audio embedding and video embedding, but I think that is also supported in SingleStore. But I used here basically a simple, and yeah, I think metadata, everything can be stored in SingleStore, right?
I think that's correct. Akmal, you wanna confirm?
Yes. So
Great.
at the end of the day, I mean, if you think about it, what is a vector? It's just an array, okay? What you're simply doing is you are converting something, regardless what it is. It could be text, could be an image, could be sound. You're representing that in a kind of numerical way. And what a database is good at, they're great at storing numbers, they're great at storing text, and they're great at giving you the ability to query that data at scale. And so, if you have that representation and you have the ability to kind of analyze that, if you like, by looking at, say, doing similarity searches, for example, or full text searches, or whatever it is you're trying to do across that data, as long as you've got that data into the database, typically it's going to be, just an array, a series of numbers. That's all you need, and the database can handle that. No worries about that at all. You can get the data in very easily, you can get it out very easily, and you can query it as well.
Awesome. Akmal, I'm going to give you another question.
Yeah.
This one is from Raghu Kumar, and it's very relevant in some of the stuff that we're going to be doing this week. And you're allowed to, we're not holding anything back from the Wednesday webinar, so you're allowed to talk about that. But Raghu's question is, can you tell me about scenarios in which search queries get slower or the database can become slow? And I'm just thinking about, some of the new features that are coming out that are all about speed and performance for this stuff.
Yeah, so that's a great question. So thank you very much for that, Raghu. So one of the scenarios that you might have, for example, if traditionally you're doing what's sort of K nearest neighbor, is if you've got vast quantities of data, and therefore it's very difficult to be able to do search across large quantities of data at speed, at scale, simply because the search space is so big. And so one way around that is this concept of, approximate nearest neighbor. Essentially, you're giving up something for the fact that, okay, you may not get an answer that's absolutely 100% accurate, but it's near enough, it's good enough, and it gives you lightning fast access to your data and returns those results really, really quickly. And so ANN's indexing, and it's in the documentation, by the way. It's all this information, all the different types of ways that you can use ANN. It's already in our docs. It's already on the web. You can consult that. You can see that. And yes, there'll be some demos and examples of that on Wednesday. But that's a great example of where sometimes, the way that you're searching the data, it can become a kind of a roadblock almost, simply because you might have billions and billions of data points that you want to look at. And existing techniques just don't work particularly well. Therefore, you make a little bit of a sacrifice to say, all right, I'll give this up, but in return, I get really fast access. I get something that's good enough for my purposes. And I think that's one of those sort of scenarios where, indexing makes sense. ANN is a good solution. And that's one of the ways that you might utilize this technology.
Good stuff. Pavan, I'm going to give you this one. It's from Mohammed. It is, can you talk about the integration of SingleStore with LLM frameworks such as LangChain? Thank you.
Yeah, we have an integration with LangChain and others also. I have written a complete article on that. So if you text me on LinkedIn, I can give you that tutorial that I have written. Yeah.
Good stuff. Let's see. There's been a couple related questions. I'm going to grab Fabrizio's here, Akmal, and it's, his question is, in our company, we use Oracle, SQL Server, MySQL, SQLite. What's the best approach to understanding how to migrate the vector database? We're dealing with millions of records.
Okay, that's a great question. So one of the solutions that we are developing at SingleStore is this change data capture, CDC. And so already we have this capability with MongoDB. I believe it's MySQL as well, other products in the pipeline, I'm sure. I can't give a commitment because I'm not in product management or product engineering. But that's one way that, for example, you could keep existing investment in the technologies that you have right now, and simply because you may be tied to sort of contractual agreements and so on, and give you the opportunity to utilize the vector capabilities of SingleStore, for example. So there are ways and means if you want to do like a full migration from one of those technologies across to SingleStore. We have consultants that work with enterprise organizations all the time working on these sort of projects and we have the skills internally. Okay, so just reach out to us and we can put you in touch with one of our consultants who can happily discuss that with you and your requirements in more detail. I think that's a great problem and a great challenge. At the same time, we realize, of course, that, you as a customer may have invested a lot of time, effort, and money using some existing technology, and it's not very easy to just give that up. But at the same time, you would like to take advantage of some of this cool stuff that's around today. Semantic search, for example, the ability to store vectors, Gen AI, all of this stuff. And with SingleStore, you can do that. So in a sense, you can get the best of both worlds. Hopefully, in the longer run, you'll be able to move across fully to something like SingleStore.
Awesome. Thank you, Akmal. Um, Pavan, I'll give you this one from Chakra. Can you explain more how those scores are calculated with respect to the numerical embeddings? Also, will these differ based on which LLM model is being used?
Yeah, the LLM model here I use like from OpenAI. So the embeddings from the text embedding that I used. So it's basically a neural network. I don't know exactly how it's calculated. It's more of a hidden thing, right? So yeah, that's how it is. Akmal, how the score is calculated, do you know? Because it's more of it depends on neural network, is what I know.
Oh, my apologies. I was just trying to respond there. Could you just repeat that, Matt, Pavan?
Yeah, it's about how do the numerical values get generated with embeddings? And I
Oh,
don't I
you
don't
mean
know.
the actual
Go ahead.
embeddings themselves?
Yeah.
Okay, so typically then you're asking, you send some data across to the LLM, right? It has some algorithm transformers and things that it's already knowledgeable about. And therefore, what it sends you in return is that kind of vector representation of what the text that you've sent it. If you want the details, that you'd need to, I think, go off and read some research papers. Generally, though, as an end user, you typically your request is simply to the LLM. Okay, you're relying upon the knowledge and the techniques, the algorithms, the way that the LLM behaves, if you like. I mean, those things are generated for you and sent back. And these are just, remember, these are just numerical representations based upon some something that it's been taught, some approach that it is aware of, some way that some techniques that it has at its disposal. This is why, for example, different LLMs will give you different results, and whether you can go down the commercial road or the open source road, there's a wide range of choices and issues associated with that. But essentially, I mean, it's like, for example, I would send Matt my address in English. I could say, I live in this part of London and here's my postal code and so on and so on. And Matt might convert that into French or something. And he sends me the answer back in French. How he does that, it's entirely up to him. He might use some third-party technology to do that. He might actually know French very well and be able to translate that for me. So he generates that for me, and I'm relying upon him as a service to just simply give me the information back in a different format. Okay, and that's something I can just store in my database then, and then maybe French speakers, I can ask them, they can query my database system. Okay, so you're really relying upon the technology to do that for you. If you really want to drill down to it, like I said, go and read some research papers as a base way to learn how these actually things work under the hood, under the covers.
Good stuff. Here's a good question from Abdullah, and Akmal, you'll remember this question. We've gotten this question in previous webinars too, and Pavan, I'm sure you might have some thoughts on it too. But the question is, are there tips and tricks to consider when making chunks from our documents, chunk size?
Oh, yes. So I think this is always a great question. I think it comes up very often. How to decide that if you've got like a big document, obviously there's a limit in terms of how much of that document, for example, you can send directly to the LLM. The token limit that it has in terms of what it can send you back. Now, these limits are getting better and better all the time, and it can consume more information all the time. But it makes sense to divide that document up into smaller parts, to make it into a size that is, either not too big and not too small, something that is within the limits of what the tokens that you're going to get back, the representations, the embeddings, and therefore it's a bit of an art. I think there are tools and techniques coming along in this. What I'm thinking of is deeplearning.ai, which is the website from, I've forgotten the gentleman's name. He's the founder of Coursera, and I think he's teaches at Stanford as well. His name is on the tip of my tongue, but it escapes me for now.
Is it Andrew?
Yeah,
Yes, that's it. Yes, that's the gentleman. And so they regularly have these kind of almost weekly training sessions, free training sessions, and there's a whole bunch of really cool stuff coming along. And some of these topics get some prominence in those. And so the tooling is getting better. It will, the automation will come. But so far, it really is a decision. I think often you have to decide, how much in terms of the size of the documents you want to deal with. Like I said, you don't want things too small, you don't want things too big, something reasonably, and you want some kind of overlap as well, okay, between them, because you tend to break things up in the middle of a sentence or at the end of a paragraph or something like that. Lots of considerations. Great question. Sorry, I don't have a great answer for you. I mean, it's a challenge, I think. But I think the tooling is getting better. I mean, definitely the automation is coming.
Awesome. Good stuff. We've gotten a lot of questions about, the recording for this, any like repo or follow along. Rest assured, everyone is going to get a copy of this recording, and we'll also get a copy of Pavan's blog to be able to follow along. So I'll knock that question out now. There's another one, Pavan, I'll give this to you. It's from Anurag. And it is, I can see that the embeddings were manually copied from Postman to vector database table. Is there an automated way to do this to directly connect to the LLM and store the embeddings?
Yeah, I think great question. We have a notebooks feature. I think SingleStore notebooks. I think from there also we can automate this embedding creation. But I use this method just to show how to create a workspace and how to create a database. I think from the notebooks also we can automate creation of these embeddings. Yeah, you guys can go to singlestore.com and then sign up, and also we have this, like I said, right, notebooks feature, just like Jupyter notebooks. Yeah, again, I'm gonna write a tutorial on that also, right there, where you can create the embeddings and store them very easily.
Awesome.
Yeah, Matt, I just saw a great question. Vignesh was asking, basically, could you reverse engineer? I thought that was an awesome question. No one's ever asked that before. So essentially, whatever you're stored in terms of your embeddings in your database system, could you reverse engineer it back to the original thing, what it was? I haven't got an answer for that. Pavan, I don't know if you've come across that or not, but that's an awesome question.
Very good use case to write an article, like do some research and yeah.
Good stuff. I see, there's been a couple questions like this, and I'll try to combine them as best as I could. And Akmal, I'll give this one to you. Probably the most succinct version of it is what I'm looking at right now. It's from Anonymous. Can you list off SingleStore's competitors? When and why would I opt for SingleStore over the others? And I know that could be an hour-long answer, but maybe you can do your best to summarize quickly.
Okay, so basically, if you look at the product, let's just take two of its capabilities. We talked about these a little bit earlier on, the OLTP and the OLAP. Okay, so the ability to do online transaction processing, OLTP, this is where the product came from originally. And the analytics side, the OLAP side, was added later. So we can do both through a single table type. That's a fairly unique thing. Find another vendor that can do that. They may be able to do that through, plugins or add-ons, or, hooking up with other external sort of technologies, and maybe that can be automated as well. But within SingleStore, you can do both of these things. And on top of that, you can do a whole bunch of other things as well, such as time series, geospatial. You can do JSON. And we are MySQL wire compatible and MongoDB wire compatible. The vectors that Pavan covered today, I mean, we support all of that with all the cool stuff coming on Wednesday as well. So essentially, from the developer's perspective, if I put my developer's hat on, this is great for me because I don't have to learn half a dozen different products. I can now just work with a single product that does all of this stuff. And B, if you're a business leader, it's great from your perspective because now your return on investment, your total cost of ownership is lowered because, again, you've only got one product that you need to deal with. In this space, I am not aware of any other company or any other product that's on the market today that does everything that we do. There may be some elements of, some of the stuff that we do that other products and other vendors do as well. But the comprehensive range of capabilities that we provide, again, I don't know of any competitor that does that. And that's a sincere and honest view. And I've been in the data business, as you can see, in sort of loss of hair, 30 years now. So I've been there a long time.
Good stuff. I see another follow-up question. This one, it kind of related, from Abdullah. If we just need a vector database for RAG chatbots, is SingleStore a good choice? SingleStore, I know, offers general purpose capabilities. I don't know if we necessarily need those. And I'm just thinking, Akmal, about some of the, like the RAG demos that have been done recently. Like, I don't know if you saw Eric Hansen's this week, the RAG on Wikipedia, which I'm going to put a link to, but I just wonder if you could talk about that question a little bit.
Yeah. So Pavan showed you essentially how easy it was to work with vectors and SingleStore DB. I think the question was absolutely correct in the assumption that, yes, SingleStore is a general purpose database system. It is designed to be that way. It can support a wide range of capabilities. We do support vectors and we do it really well. And that support is going to be much better. It's already, like I said, it's already in the documentation. You can go and try it out today, but wait till Wednesday, attend the webinars, see all the cool demos, and you'll see the benefits that you get from this. I think if you're only looking for just vector support and you have no requirement for anything else, then yes, I agree. It may be that SingleStore is not the best, not necessarily the best solution, because if you think about it, look, you're just using it for vectors and nothing else. You're not taking advantage of any other capabilities. In that case, why not just use a library such as one of the free and open source libraries that handles vectors? That might be a good solution for you. That might be a good way forward. So seriously, I think the key benefits that you get from SingleStore is, yes, the vector support, but typically in enterprise people want to ask more than just vectors. They want to build more than, they want to do full text search, for example. They want to be able to query the database in other interesting ways, not just on the vectors. And SingleStore has those capabilities as well. So if you want to utilize those, it's a great choice. If, on the other hand, yes, to be honest with you, if all you need is vectors and nothing else, think about that carefully, okay? Because you may not be taking advantage of all the other features and capabilities that the product has.
Good stuff. I see another question in the chat. It seems like our event on Wednesday is just very, very timely given the questions that are popping up. But this latest one is from Samak Hussein. I've been working with unstructured data. Do you think in the future the vector databases will overtake and we can make proper migrations? And so, yeah, again, Akmal, I wonder if you can talk about some of the structured data versus unstructured data aspects of SingleStore.
Yeah. So at its heart and at its core, it is a relational database management system. But if you think about it, it extends the capabilities of that significantly. I already touched upon some of these things like geospatial, time series. We do JSON, for example. And JSON is one of these things that, people talk about kind of schema-less, you can add things, remove things. They can be of different lengths, for example. Documents can be very different, okay? That's not necessarily the case with relational, where you tend to have a much more rigid sort of schema. But the thing is, SingleStore can handle these as well. We have SingleStore Kai that is MongoDB wire compatible, okay? It can support if you're building mean stacks or MERN stacks, for example, very easy to move across and utilize those capabilities. I think looking at the vast majority of data in the world, it probably is unstructured. We impose some structure upon that to give us some ability to control the data, to be able to query it, to have some insights into that. I think longer term, Whether vector databases become the dominant technology, hard to say. All I can say, I've lived through waves and waves of database systems. So I went through that period of object-oriented databases, XML databases, NoSQL databases. Some of them have come and gone, and some have stuck around for a while. Okay, I mean, it's one of those things. But what is the dominant database technology still today? It is still relational. And we still use that for the vast majority of business and enterprise applications. You know, maybe this thing will become, you know, after I retire or something like that. I don't know. But I think for the foreseeable future, I mean, the relational is going nowhere. We can handle the unstructured elements of it as well. And it gives you all of the benefits that have come with the research and history of relational technology at over 40, 50 years. I mean, that's the real benefit that you get.
Awesome. Pavan, I'm going to give, I think we got time for maybe one or two more questions. But I wonder, could you jump to, I think I put it as the last slide in your deck.
Sure.
But it's you know, we've just been talking so much about this event that's on Wednesday. I want to give people a chance to see this again. I'll put this link into the chat in a minute. But again, I think we have one or two more questions available before we can wrap up and do the AirPods winner. But Pavan, I wonder, I know there's like 50 open questions in the queue. Have you seen one that you really wanted to answer without me cherry picking my favorites? Is there a favorite?
There are a lot. I'm just going through. I'm very active on LinkedIn. I mean, like, you guys have anything, you can just ping me there. I can also answer there.
That sounds good. I wonder if you know, one that I've seen, Pavan, that's come in a couple times, that I wonder if you could speak to, since I think you've done a webinar on this and maybe have another one coming in the future. But just like at a high level of like, what is SingleStore versus LangChain or Llama Index? Like, how do these things fit in together and complement each other?
Yeah, so LangChain, Llama Index, all these things are like frameworks to build generative AI applications, basically. So we support all the integration with LangChain and other frameworks. So yeah, I mean, like Akmal said, we do a lot of things, and also on Wednesday, I think we have many cool features coming up where I don't want to reveal most of the things. So yeah, we do vectors, like vectors. We support vector search, full text search. Yeah,
Awesome. Awesome event coming up on Wednesday, 2 days from now. We will be presenting the new Meet SingleStore Pro Max data platform. Lots of new, cool, real-time AI features that our engineers have been working on. We've referenced a few of them here. And in addition to that, we also have our new free forever tier. So really exciting event coming on Wednesday. Highly recommend you check it out. I have put the link in the chat again. It's the bit.ly Meet Pro Max Powerhouse Edition. Hope to see you there on Wednesday. And then the announcement you've been waiting for, today's AirPods winner goes to Arhak Norsoyan, Senior Database Engineer at Questrade. Thank you. Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day to anyone who has tried out Pavan's demo. So keep an eye on your inbox. You're going to get a recording to this webinar, Pavan's blog link, and give it a shot, try it out, and hopefully you'll be our next AirPods winner. Thank you, Pavan. Thank you, Akmal. Awesome webinar today. And thank you to our audience for joining. Have a great rest of your day, everyone.
thank you. Bye bye.
Bye-bye.